Now that we know how to subnet, the next step, of course, is to implement our addressing scheme to a network. And this is where we did this lab. But for the sake of those who are not in class, I would like us in this video to go about it together so that we are all in the same page. So you can see from the learning objectives here, we're supposed to subnet the IP address that is given, configure or assign appropriate addresses to the interfaces and document all that. So the IP address that is given is 192.168.1.0. So they only have one block. So here we are going to do a bit of VLSM so that we fill in all the addressing table, or essentially come up with an addressing scheme that we will implement on this network. So let's go to the whiteboard. So I have written that IP address and the host requirements. So this is a typical VLSM example, and now that we know how to subnet using VLSM, we can just start. So so I said with VLSM we always start with the highest host requirement. So we do 192.168.1.0/24. so we'll start with 30 hosts. So we write our handy binary chart 4, 8, 16, 32, 64, and 128. So 30, we don't even need to go all the way to 128. We can obviously see that our x here is for us to get 30, our x have to be 5, because 2 to power 5 will give us 32. So 2 to power 5 will give us 32. And remember, for hosts we have to minus 2. So in this case we'll have our exact host requirement. Yeah, remember that this network that we are trying to implement here could be a company that have say R1 as the HQ. Yeah, HQ, so that you can see this could be their first branch. So we want to come up with an addressing scheme that will suit these guys. So once we do that first step, we know the drill by now. So convert the subnet mask into binary. This case is 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. Dot 1 2 3 4 5 6 7 8. So we just count our 5 zeros because we cannot have 30 computers or host assignable IP addresses to the host without 5 host bits. So we count 1 2 3 4 5 5. Yeah, so these 3 ones zeros are borrowed, they are masked to become network bits. By doing that, we'll have created 2 to power 3, which is equal to 8 subnets. Yeah, each and every one of those subnets will have an increment or a range of 32. So this was I was saying that you know the ranges by taking 2 to power host bits, and host bits are the zeros in your subnet mask. So it is 2 to power 5, which will give you 32, and that's what exactly we have there. And also this way I was saying that if you write 1 2 4 8 16 32 64 128, you can see that this 32 there matches with the last bit. Yeah, so the increment is happening at the 4th octet, and so anyway, to list those 8 subnets, we do 192.168.1.0/27. It is now no longer a /24 because we have added 3 bits. So we do 192.168.1.32/27. So we have 192.168.1.64/27. 192.168.1.96/27. 192.168.1. Now 96 plus 32, that would be 8128/27. So I have listed 5 of the 8 subnets, but I think you get the drill. So we take this first subnet and assign it to the LAN of R1. So this is where we'll have 192.168.1.0/27. Remember that when you do that, of course, if you are to complete this whole subnetting, this is where we would have the table where you have first usable, so first usable, last usable, and so if you were to come up with our table, this is where I said that you always want to start with the broadcast, because is so you do 192.168.1.31. yeah, 31 is the last IP address, such that if you add 1, you go to the next network ID, or to the next subnet. So the first usable, of course, here we can see is 192.168.1.1/27. So we have 192.168.1.30. And you can see that the usable IP addresses, if you count from .1, .2, .3, .4 all the way to .30, that's how we have 30 usable IP addresses. So our lab requires that we assign this interface the very first usable IP address, which is .1. So the PC, we can give it .30, but if we have other PCs in that LAN, we can give it .3, whichever IP address, so long as is part of the usable IP addresses in that subnet. So in fact, we're supposed to fill in the addressing table. So first Ethernet interface of router 1 will have 192.168.1.1. The subnet mask is 255.255.255.224. yeah, so PC1 can have the last IP address, which is 192.168.1.30. Subnet mask is 255.255.225.224. yeah, I'm getting all that information from what we have said, that the router interface here is assigned the first usable, this is assigned the last usable, but you don't have, as in you can do whatever you want, so long as those IP addresses are within this subnet. So The lab then requires that where is my lab? So, and this is where we are following. So but anyway, this lab is a bit confusing. So as we have gone with the R1 being like the HQ, so it will take the highest. So now we subnet for the LAN of this other router. And as we're doing this lab, because we are going to implement it on Packet Tracer, it's like part of the last chapter in CCNA1, which is build a small network, and from there we naturally transition to CCNA2, where we will see what we need to do once we implement it on Packet Tracer, what we need to do so that PC1 can be able to reach PC2 and all that. So anyway, I think I'm jumping way ahead. So we go for the 15 hosts. So I said with VLSM, so now that we are done with that network, we take the next available, which is we take the next subnet, which is this one here. So we start with it as if we are subnetting afresh. So we do 192.168.1.32/27, and here we are subnetting for 15 hosts. So we start afresh as if we are subnetting this thing afresh. But for the 15 hosts, this is where we found out that we don't need to subnet, because if you take 15 usable IP addresses, you need to add 2, because you'll have to minus 2 to get the usable IP addresses. These guys have 50 computers, 50 employees in the LAN of R2. So we need, if you add 2, then in this case is like you subnet for 17 hosts. So if you're to write my chart of 1, 2, 4, 8, 16, 32, 64, 128, so you can see that if we say 2 to power x will give us 17, so that when we minus 2 we have 15. You can see that our x again have to be 5. So even if we write this into binary, which will have 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3, that's 27. 1 2 3 4 5. So we cannot subnet again because we have 1 2 3 4 5. So in that case, we'll just take the /27 and use it for this portion here, which is 192.168.1.32/27. So we now subnet for the 2 hosts. That's why I have these guys there. So we subnet for 2 hosts, which will give so in that case we take the .64 here. So those 2 are now used. So we just start afresh. So we take the the .64 and we subnet afresh. So for the 2 hosts, we'll need to add 2 because these are 2 computers or 2 usable IP addresses. So we need to figure for 4 because we'll have to minus 2 at the end of it. So if you have our chart of 1, 2, 4, 8, 16, 32, 64, 128. So in this case, our x, for us to get 4, so our x in this case have to be 2. Yeah, so we can write this thing in binary. So we have 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8 dot 1 2 3. That's 27. 1 2 3 4 5. So for the hosts, because our x is 2, we just count 1 2. So the rest are borrowed, or they are masked. So by doing that, we'll have created 2 to power 3, which is another 8 subnets. And our increment is 2 to power host bits. We have only 2 zeros, so our increment is 4. But for the usable IPs, we have to minus 2. So it perfectly fits the 2 host requirement. And also the increment, and I think now I have belabored on this enough. This is where you have 1 2 4 8. So 4 matches to the last bit, and that's where that is the last ones, the last of the ones in the subnet mask. So that's where our increment is happening. So we have 192.168.1.64/30. Yeah, because if you count all the ones, it's now a /30. Then we have 192.168.1.76, if I'm not wrong. Yes, and all these are 192.168.1, 192.168.1, and they are all /30s. So now, but in our case, we just need one of these /30s. So we come and implement it here. So we have 192.168.1.64. So this one is a /30. So the usable IP addresses are 65 up to 66, because 67 is a broadcast. So we can assign .65 there and .66. So here we can assign it the first usable IP address, which is .33, because the network ID is .32. So if you add 1 is .33. For the PC, we can assign it the last usable, which is .62, because .63 is the broadcast in that. So here we have a .1, and this one we have .30. So I'm just writing that to emphasize on when you subnet, you have your, as in you need to note your first usable address, last usable, and the broadcast and all that. So to fill in the addressing table, this is where we have 192.168.1.65. The subnet mask is 2. If I can write 255.255.255.252. By now you need to be comfortable writing a subnet mask in CIDR notation, like a /30, a /24, a /27. You need to be comfortable writing it like that or in decimal format. Yeah, so like a /30 is this guy there. All right, so we now fill in the rest. So for R2, the fast Ethernet interface is 192.168.1.33. The subnet mask is 255.255.225.224. For the serial interface is 192.168.1.65. For those who are lost, I'm just taking what you have filled in here. So the serial interface, in this case, for router 2, it's good that I checked it's not 65, because we'd have had a duplicate address. This is 66, so we have 255.255.255.252. For the PC2, 192.168.1.62. So we have 255.255.224. For the gateway IP address, here is 192.168.1.1. 192.168.1.33. Yeah, because we are referring to PC2, you know, the work of the default gateway is always your first, as in the IP address of the router interface facing you, because you see, for this PC to communicate with anything outside this network, it have to go through the router. So it needs to know this .33 or the default gateway. Yeah. So from PC1 perspective, the default gateway is this. Yeah. As in, this PC can communicate with other PCs. You know, they are 30 computers, but here we're just using a simple network for simplicity. So without the default gateway, these guys can communicate. They can print if they have a printer, if they have a server. The communication in that LAN, they don't need the gateway. But for them to be able to communicate to the remote side, maybe to this side, they'll need the default gateway IP address, which is the IP address of this router interface. So this is where I was saying that a router, every router interface is a network on its own. So a router is always a boundary in our network. So like that's one network. So essentially we can say that's another network. So if you were to count the number of networks, so you'd say we have 1, 2, 3 networks or subnets. Yeah, that's why we need routers to tie those subnets together. All right, so once we do that, we can now just go to implementing it on the real devices, but in this case, I'm going to use Packet Tracer, which we all have. And as I launch it, we need to have a look at the routers. So in this lesson, we are also going to look at to have an introduction into the Cisco IOS. So this is the operating system that runs on the Cisco routers. So understanding how to navigate through it is what we need for us to be able to deal with Cisco routers and switches, and that's what you'll use or you'll be tested on in the certification exam. So whereas we may use these icons in Packet Tracer to simulate routers, yeah, because this is where you can come and like some of the most common routers that we have, cheap and common, because you know, like the 26 2600 series routers. I'm opting for those because you can find them at cheaply, say maybe at eBay. But because of our lab, the way it has, anyway, forget what I'm doing right now. So we can just use the 2800 because they have what I want as, or will be able to implement this network as it is, yeah. But you can use whichever router here, because once you learn how to configure one, you, as in, it's pretty much the same. So these routers, we are representing them in these circular things, but I trust that we all know that in reality we are talking about these gadgets, yeah. So we represent them as, so those are just icons. So we are talking about these gadgets. So as we put them in Packet Tracer, so these are switches. Of course, we can see switches. This is where our computers plug into. So here we are not talking about this Linksys. So we are talking about Cisco routers. So that's how they look like physically, but in Packet Tracer, that's how they look like. So, but before we go to Packet Tracer, we need to have a basic understanding of the iOS and the iOS mode. So this stands for, so that we are all on the same page, stands for Internetwork Operating System, yeah. So it's the operating system that runs on pretty much all Cisco devices. The beauty of it is you can learn it on a very low-end device, yeah, because of the budget. Maybe that's what you can get to practice in your lab, and once you learn it, even if you go to a corporate size network, you are familiar with it. So a router is a computer, yeah, as in we all know the basic block diagram of a computer, where it has input, CPU, yeah, the good old block diagram that we used to do for a computer, where you have input, CPU, output, and all that. So this thing is a CPU. That's why it's running an operating system. So to configure it for the first time, you need this bluish cable that on this side of this is a computer CPU part of it. So here you connect it to the serial port, yeah, not the VGA. If you go to the back of those old computers, they have the serial port, not VGA, or what technically we call DB9, yeah. So you connect DB9 of your serial whatever to RJ45 that connects to this bluish on pretty much all as in routers and switches. You will you'll be able to see that bluish port that is written console, not these ones written in yellow. Those are the fast Ethernet ports, yeah, the ones that we have in our topology here. So this F00 ports is if I'm to go back to I've lost it. I have to go back here. So these are now the ports where you put your UTP cable that now goes to the switch and the LAN and all that. So but this thing, when you pull it out of the box, it is a clean slate. It doesn't have an IP address. That's why we have subnetted, and now we will assign it to the box. But so you need the console cable for to set it up from scratch. But we know that most of our computers, especially modern day laptops, this port is going away. So that's why we have this USB to serial converter. So you need that for console connection. So that's how you connect it physically, power it, with the power cable, power it on, and all that. So once you do that, on the computer side, you need what you call a DAM terminal or a console, a terminal emulation software. So there are several. We have HyperTerminal, Teraterm, Minicom, Secure CRT. This is a picture of, I think this is HyperTerminal. There are some settings that you do on these terminal emulation softwares, but by default they run these things. You might want to note them because you might find them in an exam environment, though not rarely, but sometimes you might connect this thing physically, then you don't get an output. You don't get a router output and everything is powered. It could be maybe one of these settings is off. So you might want to play with these softwares. Just to show you, I have Teraterm. So if I wanted to connect serial, now here is now, if I had that serial whatever connected, I would then say okay, but in this case, I don't have a serial cable connected. So if you come to setup, then you say terminal. There's a place where you come to do those settings. So you come to setup. If you go to serial port, this is where you are setting those bound rate and all that. So I'm saying if I was connected to a router right now and I'm not getting any output, but in this case it's because I'm not connected to anything. Perhaps one of those settings is off. You might want to review that. And I think this is exactly what I was trying to explain. I think we have seen that on the real Teraterm. Alright, so once you log into the device, these are the three basic iOS modes that, for starters, cram them, memorize them, whatever you need to do, but these are the three basic modes that we will see on our routers and switches. So once you log into it, it will come in this router, this is it greater than or less than whatever. So that signals that you are in user mode. This, because we have said your router is a computer, this would be like logging into your computer through the guest account. The guest account, you can't install anything, as in under user mode you can't do much configuration on the router. So you type enable, and I'm going to take you to the real CLI, command line interface, because we configure these things using the command line, which for many people that are used to GUI, the GUIs, they find this thing as a turn off a bit. But for us in Cisco, we need to get used to, we use the CLI to configure these devices. So when you go to privilege mode, here you have quite some rights, because if somebody gets to that mode, there is nothing to prevent them to go to the global configuration mode, where they can do some real damage on the device. Or basically, this is where we do the configurations. So from the global config mode, you go to like 1,000 other modes that will not master in CCNA, and you go all the way to CCIE, you probably will not exhaust them, not unless you do all the tracks in Cisco. So maybe this is where you do CCIE routing and switching, CCIE voice, CCIE security, all the tracks that Cisco have to offer. Rarely will you find somebody who have done all that. So anyway, I think I have belabored on that point. Yeah, so I think this is what I was saying, that these are the various tracks that we can go through. So as you know that we are in routing and switching, CCNA routing and switching, so you can see security, you can go all the way to CCIE, all that. All right, so now when you look at a router physically, I think this is the back side of the 2600 series router. It has the fast Ethernet, those yellowish whatever. So these are the ones that now we connect our RJ45, and we have a UTP that now goes to the switch. Yeah, you have my horrible drawing of a switch, if I can draw. So this is where now you have your computers, and in essence that's a LAN interface. So up here we have what we call the serial ports. At times we call them weak cards, as in one interface cards, meaning that this is where you connect your one wide area network. Those are the ports. So these two fast Ethernet are, and you can see the console. So this is where you put the console cable, you connect it to the DB9 of your CPU, so that you set up the device for the first time. Yeah, it is usually written there in that light bluish color. The auxiliary port or aux port is one that you'd connect in the good old days. You'd connect a modem. That is, if you had a landline, the old telephony landline, so that if say something have happened to your network, you cannot access your device, you can dial into the device. So now in the lab environment, we simulate that one connection, yeah, as in, you know, like in our case, the lab that we are having here. So I've said this could be HQ, this could be the branch, yeah, and this could be Nairobi, this could be in Mombasa. So we don't want to take as in to create a real one connection, yeah, just to do a lab, yeah. So in the real world, you'll have this device called CSU DSU. Now this thing is miles and miles and miles and miles of the telco company infrastructure. So on the other side you have CSU DSU. So in the lab environment, we simulate it using this cable. So in the real world, it would be something like this. So you can see our router with our bluish console cable. We are configuring it. This is going to fast Ethernet, so this now would be going to a switch, so that you have your LAN, yeah. So now this is your wide area network connection. So you can see we use one of these cables. So this side is the one that is connected there to the router. So then you have this box, the CSU DSU. So this side, and I'm actually using the wrong cable to explain. So this cable that they are showing here is this here, yeah. The CSU DSU have a female side. So in the real world, this cable doesn't exist. That one doesn't. We call it a DCE cable. This is a DTE cable. So this is the one that they have actually connected here, this V35 whatever they connected to the CSU. So now this one now goes to the telco company infrastructure with the those are posts that I'm trying to draw, yeah, going now to the outside world. So in the lab environment, we just take this cable that doesn't exist, we connect it to this other one, because you can see these are female, these are male. So the side that you'll connect the router on this side, you'll see it as DCE. So I'm trying to explain what we have here in the lab. You can see that this side is DCE, this side is DTE. That's not all that important, as in you don't need to decide which router becomes the DCE, because here we're just simulating, yeah. But so the thing is, or the reason why we bring this is when you do that one connection, sometimes your interface, your one interface might not come up because of a missing clock rate. But I think this you'd better understand it when I demonstrate it on Packet Tracer. And so now this is a zoomed in view of those I forget about this. This is still the same serial cable, but this is for an old card. This was an older card that was called WIC 1T. Now this is the one that we use. This sometimes Cisco calls them smart serial. So this newer version of cables, so this is the older version of those cables. So that newer version is the one that we use on this WIC 2T. So now this is where you'd have this smart serial, this one here, this one. So you connect it from there to the CSU DSU. Then from the CSU DSU, you might connect with a normal UTP cable to the wall jack, or what at times they call a DMARC, a demarcation point. So this is where your internal network starts from the outside the wall. That's where now the telco, the ISP side, yeah. But with the advancement of the technology, actually all these things are fading away, yeah? As in because these WIC cards worked with ISDN technology, which you know that is fading away, and all that. So but we still have things like E1 lines, T1, yeah. But normally you'd have this normal UTP cable that you connect to the wall jack and you bring it straight to that card, yeah. And that card is being, you know, each of these cards goes to these slots, yeah. In fact, when you're buying your router, it might come with just those slot covers, so that you buy whichever card. It's like expansion slots on your PC. You know, you might want to put an NIC card there, you might want to put a VGA, whatever, in those expansion slots. So I wanted us to be on the same. Now this is a closer look of those two cables. So we know the DTE cable and the DCE based on the connection. I wanted us to look at that because many people who have not played that much with the real devices, as in you need to know when you're simulating on Packet Tracer the real gadgets that you are working with. Holy cow, looking at the time, I think I'll stop there. So we will continue in part 2 of this lesson on how we do the actual configuration. So with that, I hope this has been informative to you, and I'd like to thank you for viewing.